Hola, scholars. Today we're going to actually step back into algebra mode and we're going to talk about reducing radicals, simplifying square roots. It's a really important thing for you to be able to do, and I'm going to expect you to remember this from last year. I'm more than willing to help you if you had not had it taught well to you to see the quickest way of doing things, but you are going to have to basically, at first, if this is hard for you to understand, just write down the notes, process it a little bit, come in and get some extra help on here. Give me a call tonight if you need to on my home phone. I would love to help you with it. But the first thing you have to know in order to do square roots is you have to know your perfect square numbers. Now, perfect square numbers are the numbers that are formed when you multiply a number by itself. So we need to know our perfect square numbers. Now, in my room, they're in the back corner by my desk. Really hard to see. You can't use it to help you on this. You have to know these. But you should know them all the way through 20 squared. If you know it through that far, you're pretty good. I'm going to have 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. You who had Mr. McDonald, he tried to get you guys to memorize these last year, and if you did not memorize them, your fault. Make sure that you have them memorized. It sure makes your life easier. All right, here we go. Let's plug these in. Perfect square numbers. 1 squared is 1, 2 squared is 4, 3 squared, 9, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, 9 squared, 81, 10 squared, 100, 11 squared, 121, 12 squared, 144, 13 squared, 169, 14 squared, 196, 15 squared, 225, went blank there for a moment. 16 squared, 256. 17 squared is 289. 18 squared is 324. 19 squared is 361, and 20 squared is 400. These numbers are going to be critical for us to solving the perfect square numbers. And this is just a good thing to have even when you're doing your homework. So here's all the different rules you actually learned. Okay, with radicals last year, you probably had a whole chapter on this, and then that's when you were introduced to the Pythagorean theorem. The first thing you must always do, one must always simplify. Okay, what in the world does that mean? It means take out all perfect square numbers. You have to do that. Here's an example of this. I'm going to give 3 different examples. Okay, the first one, A, is going to be like when you take the square root of 9. What's the square root of 9? It's a perfect square number, so the square root of 9 is 3. Notice, once you take the square root of a perfect square number, it's gone. Everyone knows that one real quickly. But what if I have something like the square root of 8? I look over here, 8 is not a perfect square number. So how do I simplify it? Well, you factor out perfect square numbers. So I go the square root of 4 times the square root of 2. Well, now I can take the square root of 4. Once I take the square root of it, it comes out. So the square root of 4 is 2. That's 2 root 2. That is simplified because there's no other perfect square numbers in there. Then we have C. Okay? Now, this example is using actual variables, and this is something I expect you guys to know. I'll give you more practice down later. But it's something like this. The square root of 4 x cubed. Now, squares and square roots are perfect square numbers. Let me give you a quick remember one here. To get x cubed, you want x times x times x, right? Is that the same thing as going x squared times x? Yes, that, because remember we add exponents together. So perfect squares is when you have pairs of these. Even numbered exponents are perfect squares. All right? So in this case, I'm going to write out the perfect squares. So what I get here is I get the square root of 4 times the square root of x squared times the square root of x, because x squared times x is x cubed. But notice when it's odd, I just go one less to get my perfect square number, and then I have one left over. What's the square root of 4? Straight below, 2. What's the square root of x squared? Well, what times itself gives me x squared? X. So that's 2x root x. Got to remember how to do those. All right, let's do another one. Next rule. When adding or subtracting radicals, one must have the same number under the radical. Here's an example of this. If I have 5 root 27 plus 3 root 75, Oops. I have to simplify both of these down. Now I'm going to do these very quickly in my head. I know that's 9 times 3, so that ends up being 15 root 3 plus, and this one ends up also being 15 root 3. Now, if you don't know how I got that, come talk to me later. I just simplified this. 25 times 3 is 75, so square root of 25 is 5, 5 times 3. I add them together, I get 30 root 3. All right, now, what if I have the same thing like the following? I got negative 2 times the square root of 48 minus the square root of 32. Well, I can take out the largest perfect square number that comes out of 48 is 16. 16 times 3 is 48. The square root of 16 is 4. I multiply it to the number out front. So that's a negative 2 times 4. So it's a negative 8 root 3. Minus, well, what's 32? That's 32 is 16 times 2. 16 is the largest perfect square number that comes out 32. So that'd be 4 root 2. Now, I look here. Do those have the same number underneath the radical, even though they're both simplified? No. So that's the farthest you can get with this one. All right, 2 more things we got to get done. When one multiplies radicals, first you multiply the coefficients, and then you multiply the numbers underneath the radicals. And then you always make sure you simplify. Here's an example of this, okay? I have 3 root 6 times 2 root 3. So here's what the rule says. Multiply the coefficients together first. 3 times 2 is what? 6. Then I multiply the two numbers underneath, these two, together. 6 times 3, 18. Okay, now here's the deal. Is 18 able to be simplified even more? I better hear some yeses. Because can I divide or factor out a perfect square number? Yes, I can factor out 9. So I take the 9 out. So over here, I'm going to continue over here, gives me a little more room. I can go 6 times the square root of 9 times the square root of 2. What's the square root of 9? 3. So it's 6 times 3 times root 2. What's 6 times 3? 18 root 2 is your simplified answer. 18 root 2. Some of you are like going, I just don't remember this. Got to come in. This is stuff you're expected to know majorly from Algebra 1. All right, one must always also rationalize the denominator. This is going to be huge in a few days. What I mean by that is you can never have a radical ever in the denominator. So if I have something like this, 5 root 6 times over the square root of 6, that's illegal to leave it that way, even though the square root of 6 is simplified as much as possible. So what you do is you multiply by that number underneath the radical. So I sit there and I go root 6 times root 6. What do I get here? I multiply it straight across. I get 5 root 6, because I can't go underneath because they're not like, and then I get root 6 times square root of 6. Well, that's the same thing as square root of 36. Well, here's the cool thing. That's the same as going 5 root 6 over what? When you square a square root, it comes out underneath 6. I look to see if I can simplify those. I can't. That is a simplified fraction. That's been rationalized. All right, the best thing we can do right now is practice. Look at more and more examples. I mean, this is more examples than I normally ever give you. That's almost a homework. There's 14 examples here. So first thing, let's go ahead and figure this out. What is the square root of 64? I look over here. Oh, it's a perfect square. That means it's going to be 8. So 8, pretty easy. All right, now let's look at number 2. That's not a perfect square number. So what is going to be the largest perfect square number that comes out? I look underneath 24. I got 16, 9, and 4. Which one of those comes out? 4. So I rewrite it like the following. 4 times the square root of 4 times the square root of 6. Now, some of you are good enough you can do this process in your head, and that's okay. But those of you who can't, you're going to want to write this down. The square root of 4 is 2, so that's 4 times 2 root 6. 4 times 2 is 8, so that's 8 root 6. All right, let's try another one. This was one of those you just want to memorize because it goes so quickly. But 75 is not a perfect square number. It's not up here. So I look below 75. What number goes in it that's a perfect square? 25. So it's the square root of 25 times the square root of 3. Basically, I just factored it out because remember, if I multiply them together to go opposite, you can split them into 2 different parts. So what's the square root of 25? 5 root 3. All right, 2 more on this page. We have here square root of 16x squared. Here's the coolest thing, okay? When you have an even numbered exponent, it is perfectly squared. 16 is perfectly squared. So this actually is really easy to simplify. What's the square root of 16? That's 4. Perfect. What's the square root of x squared? It should be x, okay? Should be x. Now, if it's an even numbered exponent, here's the deal. Divide by 2, put that exponent up, you got your answer. All right, let's look at the next one. What if we get a problem like this? 6 is not a perfect square number. Its factors are 3 and 2. I can't do anything with it. But these are odd. Well, you rewrite them, okay? You use them to your advantage. In fact, what I do is I pull out the fact that I can literally rewrite it like this. I can go 6 times x squared times x. What you do is you take one less away when it's odd. Unless it's x to the first and then you don't touch it. Times y to the fourth times y. So really I can almost rewrite it like this. 2 root x squared times root y to the fourth. What's left underneath is going to be 6xy. Okay, that's this one, and this one. These are all perfect square numbers. So what is, again, remember you can divide that by 2. That's x squared divided by 2. The exponent divided by 2. That should be an x. What's the square root of y to the fourth? Y squared equals the square root of 6xy. There you go. Sure worked out really well. All right, next page.